I'm Lauren McGrath, and I'm the director of the Watershed Protection Program. Here at Willistown Conservation Trust, the Watershed Protection Program was established in 2017 through a generous grant from the William Penn Foundation. The goal of our program is to really get a better understanding of the baseline function of our streams in the program area, which include the headwaters of Ridley, Crum, and Darby Creeks. We monitor our waterways every 4 weeks, going out and taking water chemistry samples and looking at the insect community on an annual basis. We're very passionate about educating our community on how to be the best streamside neighbor possible, and we hope that you will join us in learning more about our waterways. What is a watershed? A watershed is the area of land around a stream where if water falls in the form of rain or snow, it drains into a common outlet. So this is Crum Creek. We're at Kirkwood Preserve, and all of the land you see around us is part of the Crum Creek watershed. And the Crum Creek drains into the Delaware River, so we call it a tributary. And the Delaware River is an amazing source of water for over 15 million people. So protecting the water quality in small streams like Crum Creek is incredibly important. So why are watersheds important? Anywhere you go in this world, you are actually in a watershed. Take a second and think right now. Do you know what watershed you are in? Every activity that we take place in on the planet impacts our water. So if a candy wrapper falls out of your pocket and flushes into a drainage ditch, it will eventually make its way into a stream. So what can we do to be better streamside neighbors and protect our water quality? So how do we study conditions in the stream? One of the most useful tools is water chemistry. And water chemistry tells us a lot about what's happening in the water at a moment in time. Conditions are constantly changing as water is flowing and moving. And so by being able to look at what's happening with temperature, pH, dissolved oxygen, and conductivity among a whole battery of other chemistry, we can get an idea of what's going on in a moment in time in the stream. So how else can we look at the quality of our water? One of the best tools is by looking at the animals who live there. And one of the most important groups of animals are macroinvertebrates, which are insects and non-vertebrate animals, meaning they don't have a spine, that lives in the water that you can see with your naked eye. So these insects live in the water for most of their lives, which can be in some cases upwards of a year. And we know that different animals are sensitive to environmental changes. So by looking at our community structure, we can see how the water quality has either degraded or been maintained over the course of this animal's life. So when water chemistry is just a snapshot in time of our stream, the insects paint a bigger picture of what water quality has been like over their lifespan. So this tool is our YSI multimeter. And what this does is it measures a bunch of different chemistry parameters in the stream. Things like temperature, pH, dissolved oxygen, and conductivity, which all will begin to change if you take a sample of the water away from the stream. So this measures everything on site and records all of the data on the screen. And so we use this on a regular basis. If you didn't have a YSI multimeter, that's okay, because there's a lot of less expensive lower tech tools that you could use, like a basic thermometer, to find out what the temperature of your water is in your local waterway. So knowing what is in the stream is important, but knowing how much of it is in the stream is critical. So we can get an idea of how much of pollution is moving downstream during storm events and during regular base flow like today. So one of the ways that we measure the amount of water moving through the channel is with a flow meter. So this is a great little tool. It's got a little fan at the end with two little reflectors and it counts every time the reflectors pass each other. So this goes into the water, and as the water flows by, it spins the fan, and we can get an estimation of how much water is moving through the channel at once. That's our discharge. Once we know our discharge, we can use that to calculate the amount of contaminants in the water, like sediment, or nutrients or anything along those lines. And so we can get an idea of how many tons of sediment move through our waterway during an event.
To measure discharge, we have to know a few different things about our stream. First, we have to know how wide our stream is, so we set up a tape measure and record the width of the waterway. We take measurements at regular intervals to get an idea of how much water is moving through the channel at one time. Once we know our width, we also need to know our depth at each location, and we measure that using a meter stick. Finally, we use the flow meter to record the velocity of the water, or the speed in which it is moving through the channel. Once we have these three pieces of information, width, depth, and water velocity, we can do some basic algebra to calculate how many liters or gallons of water are moving through our stream. This measurement is called discharge, and we calculate discharge to help give us some context of how much of a given substance, like sediment, is being moved through the stream at any time.
So how can we protect our waterways? One of the best ways to protect our water quality is by protecting the land around the streams. And we do that here at the Trust by conserving open space and easing private property to protect it from being developed. When you develop the landscape, it reduces nature's ability to absorb water during big storm events, and it increases the temperature of stormwater, and a lot of grit and dirt and pollution enters the water a lot faster than if you had a natural open space, which buffers and protects our waterways without any of our intervention. So how many people does it take to monitor and understand the health of our waterways? In reality, it takes a village. And we're very proud to have partnered with amazing people like the Academy of Natural Sciences of Drexel University, who assists us on a regular basis with our monitoring, our data analysis, and our sample analysis. Our other partners include Stroudwater Research Center, who we work with very closely to install, maintain, and monitor data coming in from Enviro DIY sensor stations at 4 locations throughout our program area. 2 of which are located at Ashbridge Preserve on Ridley Creek. So when you're walking through, please take a second and see the sensors and check out our website to learn more about the data coming in. We're also very proud to be partnered with the Darby Creek Valley Association to begin a citizen science monitoring program in the headwaters of Darby Creek. More information on that is available on our website if you want to learn how to become a citizen science volunteer. And we're very, very honored to be funded by the William Penn Foundation, whose efforts throughout the entire Delaware River Basin have led to an increased understanding of how our human activities are impacting the health of the waterways,